Welcome to Train Signal. You're watching Advanced Distributed Resource Scheduling Configurations. So now let's talk about understanding DRS and DPM. DRS, or Distributed Resource Scheduler, balances the workload in a cluster. So it looks at the VM memory and CPU usage, looks at how the hosts are, sees if there's anything overloaded or constrained, and then vMotion things around and tries to balance out the cluster. Another useful feature that it has is when you power on VMs, it tries to figure out which host the VM should come up on, because you don't want to bring up a VM just randomly because it may be on a host that doesn't have a lot of memory or CPU available. So it'll look at that and figure out the best placement for power on. DPM, or Dynamic Power Management, shuts down hosts when they're not needed. So your VMs are running fine, but when you look at it, they're not really stressing the cluster. So what it'll do is DRS will vMotion VMs down, evacuate them all off of one or more hosts, and then shuts the host down to conserve power and cooling. DPM is pretty neat. I've yet to see anybody really utilize it in production. I know there's a few places that do, but most people do not. My only real issues with DPM are it does a full-on shutdown of the vSphere host. It doesn't put it in standby to do it quickly. It shuts it down, and then when you need it again, it boots the vSphere host back up. And that takes time. You know, if you boot a vSphere 5 server up, it's got to go through all the post tests and everything, and then load vSphere and do all that. So that's my one issue. Other than that, it seems to work fairly well. And it is smart enough not to be bringing hosts up and down quickly. When it brings a host back out of shutdown, it will leave it up for a good bit of time before it'll try to shut another one down. So it doesn't go crazy with it. So DRS, again, this is Distributed Resource Scheduler, a thing that's balancing the load across your cluster, is enabled at the cluster level. You need to ensure proper vMotion configuration, because DRS will enable even if you've got hosts that can't vMotion to other hosts. It's not going to tell you that they can't. You're just going to notice an imbalanced cluster. So confirm your vMotion configuration. Once enabled, there are several options, such as automation level, DRS groups, rules, VM options, and power management, which is really DPM, because that relies on DRS. There's also some advanced options for tweaking settings. There are 3 levels of automation, and this is probably review for a lot of people, but it's worth noting because these are things that I think are very testable, again, on the exam. Manual, where vCenter will make suggestions which you can then act upon. Partially automated, which is basically that DRS will do VM placement at power on, but no other balancing is done, so it doesn't vMotion things around. It'll give you recommendations, and again, you can tell it to go do it, but it won't do it automatically. And then there's fully automated, where it does VM placement at power on, and it balances the load. Most people have moved on to fully automated. It's rare that I find an environment that's not fully automated. In the old days, back when this was new, people didn't really trust it yet, but now DRS is very common. When setting the level to fully automated, you have to set a migration threshold, and this basically just defines how aggressive DRS is. Starts at 1, which only moves VMs as needed to stay within rules and maintenance, which is not really helping you as far as load balancing, all the way to 6, which can be very aggressive. So if it sees a little bit of imbalance between hosts, it'll try to fix that. Most people see it at 3, which is the default, and it seems to be adequate. Doesn't seem to be vMotioning things too often, doesn't seem to be leaving things unbalanced, so I think 3 is probably a safe bet. You can also set DRS groups and rules, and the bottom line is that often you want VMs to either stay together because they do a lot of VM to VM traffic and it's best to leave them on the same host so things don't traverse the network, or you may say I don't want these 2 VMs on the same host. In case the host fails, it's maybe a cluster or a group or a farm of servers and you want to keep them spread apart. So you can do this a few ways. So DRS groups allow you to combine items. You have host groups, which are groups of hosts, go figure, and VM groups, which, as you probably already guessed, are groups of VMs. And groups do nothing by themselves. I group hosts, I group VMs, they just sit there and look at each other. Well, then you have rules. Rules allow you to set affinity, or anti-affinity, as the case may be. You can assign VM groups to certain hosts. You can specify that a VM group does not run on a certain host, which is anti-affinity. So basically I can say this group of VMs or these 3 VMs have to run on these sets of hosts or do not run on those sets of hosts for different reasons. Rules can be set as should or must. Should means DRS tries to enforce the rule but may not due to host failure. So if HA restarts VMs, it'll try to do it, it should do it, but if it can't due to HA issues, basically when you say a should rule, when it's more important that a VM be up, then it follows the DRS rule. Because if you say, hey, this must run on this host right here, and that host fails, a must rule will stop that VM from being restarted. A should rule will restart it on another host, which isn't optimal, but better than the VM being down. So must means DRS will follow the rule even if a VM cannot be restarted. Virtual machine options, basically you can go on a VM by VM basis and override all the stuff we just talked about. You can reset the automation level, you can manually override on a VM basis, you can say specify a certain level for a VM, you can disable DRS for a VM, you can do all kind of stuff. Use disabled if you don't want DRS to manage a VM. So maybe you want to pin, well, even if you want to pin a VM to a host, I'd probably use a rule. But if for any reason you don't want DRS to move a VM around, you can set it to disabled. Keep this stuff in mind. Anytime you go add exceptions, such as disabling this or specifying a different automation level or something for specific VMs, or just using groups and rules, you make DRS's job harder. And think about it. If I say, okay, these VMs have to be on these hosts, those VMs on those hosts, this VM's tied to here, that one can't run there, and DRS is standing back going, all right, well, I got all these rules, and now they want me to balance the cluster. Well, it can only do it within the constraints that you give it. So keep that in mind. If you go too crazy with rules, you make DRS's job a lot harder. And that's where we see things like vCenter memory and CPU usage go up, oddly enough. I've hit on this in the HA lesson, but Duncan Epping and Frank Denneman at VMware have written a book, and they've revised it with every major version of VMware. The latest one is 5.1, and it's their HA and DRS deep dive book. It's a fantastic book. I think every vSphere admin should read it and own it. But they kind of cover what happens when you start adding rules and complexities go up, and you see why, CPU requirements go up on things like vCenter, because that's the guy doing these calculations. So just keep that in mind when we do exceptions. So DRS uses the migration threshold to define what is called a target load. So there's a screenshot from vCenter. We'll see it again in a minute. But it says target host load standard deviation is less than or equal to 0.2. Current standard deviation is 0.115, so everybody's good and happy. As you set this to be more aggressive, that number gets tighter, and it has to do more work to match it. If the load is imbalanced, DRS will migrate VMs around as needed. So there you go. There are some extremely complicated formulas behind all this. I'm not going to get into that. You don't need to know it. You're not going to be tested on it. If you want to read it, go buy Frank and Duncan's book. They talk about it. It gets very complex. But what you need to know is the higher you set the automation level, the more work DRS has to do. It tries to keep things closer together. And the more rules you impose, the harder it is. So when HA, high availability, restarts VMs after a host failure, DRS can place the VMs on the proper host. That way you don't have a single host bottlenecking restarts of VMs, but you have to set the proper automation level. And really, any automation level is going to do VM placement. Well, I guess except the manual. But partially automated will do VM placement but not move after. Fully automated does placement and movement, so you at least want to be partially automated. And DRS is also kind of neat in that, okay, you got a host fail, and I got to restart this big SQL Server VM, but no single host has enough free memory to manage that VM. So DRS will stand back and look at it and go, I bet if I move these VMs over here and that VM over there, I can free up enough space on host number 3 to start that VM, and that's what he'll do. So it's not going to try to shove a VM onto a host that won't fit. DRS will try to rebalance it and then let HA restart that VM. So it adds another level of intelligence to high availability. So now let's go to the lab. We're going to review the DRS requirements, enable DRS, show DRS configuration options. Here we are back in vCenter. So we click the cluster. Let me move this guy over. And all of your configuration settings are under the settings for the cluster. So we already looked at HA. Let's look at DRS. So the first thing we have to set is automation level. I am, like most people, fully automated, and the default is 3. You can scroll this guy up, which will apply any and all recommendations, even for the slightest improvement, all the way down to very conservative, which will only apply recommendations that must be taken to satisfy affinity rules and maintenance. I want it on 3, which is that happy medium. And also remember, again, partially automated. VMs will be automatically placed onto hosts at power on, and vCenter will suggest migration recommendations for VMs but not actually act upon them. So that's just going to do placement. This does placement and balancing. If there are other settings you need to add, here's your advanced attributes. I don't really have any for DRS. It's not something that I ever have to manually do, and I can't think of any tips or tricks to give you for the exam there. So the only thing I'll say is if they give you one, they're going to tell you which one to do. And they say go apply this advanced setting to DRS. This is where you do it. Then we move on to groups. So I actually do have some groups here for a couple of reasons. Some things I was doing for testing. I'm testing a product called Zerto for replication. It creates these by default. But you have two types of groups here, virtual machine groups and host groups. So if we do add, and we're going to do a VM group, this will be vcat VM group. And all you do is pick some VMs and put them in the group. Easy. And then if you want to create a host group, you do add, give it a name, pick a V. You can do one. It doesn't have to be more than one, but you can do two hosts. So even if it says a host group, you can just do one and say OK. Then groups are nothing without rules. So then we add a rule. So we go down here, we click add, name of the rule, vcat demo rule. And by the way, this tab over here is basically the screen that I showed you. So if you get here like me and get ahead of yourself and you forgot to create your rules, or your groups, you can do that here. But then it's going to say what type of rule. So do we want to keep VMs together? And if we do that, we can say add and just pick a bunch of VMs, and as one gets moved, they all get moved. That's easy enough. Like I said, if you got a pair of VMs you want to always move as one unit, that's an easy way to do it. If you want to separate virtual machines, you can do that. So if I never want these two to be together, we can keep them split. So this is kind of your affinity rule for keeping VMs together. That's your anti-VM affinity rule. And there's your VMs to host, and this is where your groups come in. So cluster VM group, which is basically really what that means is your VM group. I don't know why I call it cluster VM group, but VM group must run on these hosts, should run on these hosts, must not run on these hosts, should not run on these hosts. So you've got affinity rules, VM to host affinity, and then VM to host anti-affinity rules. And remember, must will always enforce this, even if it means it can't restart a VM after a failure. And you've got should, which means it'll try to enforce this, but doesn't have to. So we'll say should run on these hosts. So this will mean all the VMs in our rules, in our group, will try to run on the hosts in our other group. And we say OK. And you can, of course, go in here and edit these. You can click details. It's kind of boring, actually, but you can click it. And you can just say OK, and off it runs. I'm not going to do that. But that's how you set up a rule. Really simple. Just remember, if you want to do hosts or VMs to host, do your groups, VM group, host group, and then you say this must go on that, or should go on that, or must not go on these, or should not go on these. Then you have VM options. So this is where you override your automation level. So again, if I got vCloud Director and I wanted to be fully automated, even though I've set everything else to be partially, I can do that. I can do disabled, which does keeps him out of the DRS stuff entirely, so it doesn't balance him. But you can override this just like you would do for everybody, but you can override it on a per VM basis. Let's see, kind of like what you can do with HA, where you can do priorities. You can do that here. For example, I have vCenter out of this for now because I've got it pinned to a host. Since I run a virtual vCenter, I like the vCenter to come up on a known host if I have to power down my whole setup. We're not going to do power management or EVC yet. We'll come back to those. And here is your DRS options. It shows our migration level, if power management DPM is on or off, any recommendations that need to be applied, any issues, what our migration thresholds are, what our load deviation should be, and what it is. You can look at a distribution chart which shows your 3 hosts by CPU and memory, percentage or hard numbers, and see how the load is. You can also view the troubleshooting guide, which will just take you out and pull up the troubleshooting guide. Not a whole lot you need to worry about there, but good to have. But all in all, DRS is very simple. You can hit the DRS tab at the top under the cluster, and it'll show you any recommendations. So if they're blank, you can hit Run DRS here. And if it has any that it has not applied, it will list those. You can click it and hit Apply Recommendation. So if you've got it set for, partially automated, you can come here and say, all right, tell me what you would do. Okay, you click the ones you want to do, say apply, and then you'd say, oh, I don't want these or those, and you don't have to apply them. Shows our faults, shows the history, basically our placement in any movements that have happened. So, you just look at it and manage it there. You can hit here and it takes you back to the cluster settings. All in all, DRS is pretty hands-off for most people, but it's a very useful tool. Next is DPM, or Dynamic Power Management. So DPM can shut down hosts if extra capacity exists. Like with DRS, you set an automation level, and it does require DRS to be enabled because DRS does the work of checking load, moving things around, and all that. Really, if you're going to do this, you need to set DRS fully automated. I mean, you can do it partially automated and then manually take recommendations and then manually take the recommendation to power down a host, but it kind of defeats the purpose if you're the brains of the operation saying yes or no every time. DPM does an actual host shutdown, so I mentioned this earlier. It doesn't put it to sleep, and it can take minutes to boot a host up. And it makes sure that extra capacity is available for a while before shutting hosts down. Meaning, as soon as resources free up, it doesn't quickly shut a host down. It waits a while. It'll wait 15-30 minutes easily before it'll shut a host down again. A couple of options. Again, automation level off, which is disabled in DPM. Manual, where it'll make suggestions, you can act upon them. And then fully automated, which automates the movement of VMs and shuts down the hosts depending on the threshold level. DPM must communicate to the physical vSphere host, so it's got to tell it to shut down. And it does not do that by talking straight to ESXi. Reason being is, once I shut a host down, I got to have a way to tell that host to power back up, and ESXi isn't running. So you've got three options. You've got IPMI, Intelligent Platform Management Interface. My servers have IPMI that I use for lights out management, all sorts of stuff. But I don't use it for this, oddly enough, because they also support Wake on LAN. So Wake on LAN is a standard for waking a machine up and booting it up across a network. And it does this on vMotion enabled interfaces. So if your servers have 2 NICs that support Wake on LAN and 4 NICs that do not, to use this with Wake on LAN, you have to have vMotion enabled on the Wake on LAN capable NICs. And then you have ILO, which is for HP servers. It's another lights out management from HP. So the communication methods configured via the VI client. Wake on LAN requires no configuration, which is the main reason I use it. I'm lazy, and when I rebuild a host, I don't have to remember to do that. Make sure you enable ILO or IPMI via your server BIOS if you need to. Same goes for Wake on LAN. A lot of times you have to enable that in the BIOS. So let's go to the lab because it's easier to show you than to explain it. We're going to enable DPM, configure it, show host communication, and then perform a test DPM shutdown and boot. So here we are again. Go back to the summary page, edit our settings, and now we go down to power management. So here's where we do off, manual, or automatic. And again, when you set automatic, you can go to conservative all the way up to aggressive. I set it again at 3. You do have host-specific options, so you can disable a specific host from going down. It's obviously not going to shut all my hosts, because the host's got to run. It will try to leave a host up for HA redundancy, of course, so it doesn't want to make it so that you can't boot VMs should one of the hosts that are still powered on fail. So it's pretty intelligent. And then it'll say what's the last time you saw this guy come out of standby. One other thing it does is it rolls through the host. It doesn't always power down the same host. It will try to power down one that has been the longest since it got shut down, just as a way to roll through the hosts and test them. As it does through that, you'll see this last time exited standby updates as it goes through. So that's a quick way to see if a host has ever been shut down by DPM. So we'll say OK. It gives you a warning right there that says one of your hosts has never actually exited out of standby. You might want to manually do it. And that's a good thing to do. But really, once DPM is enabled, it'll go through the HA stuff. We can actually test this. So like I can right click on Bumblebee and you can say enter standby mode right there. So as soon as the cluster's done, actually there it goes. I'm sorry, I'm saying this and DPM is shutting it down now. So the reason it did that is he didn't need the extra capacity, so immediately he starts shutting that host down. That was easy. So we're going to let him finish. And let's go pick another host. So again, we could right click and also say to standby him, but I'm not going to. But you can do a standby, and in a minute we'll do a power on, and you'll see that it updates the time to do it. So while we're waiting on that, let me show you how to enable communication. pick your host, go to configuration, and go to power management. So here it's going to say IPMI and ILO settings. Remember, there's no required settings for vMotion. It just works using Wake on LAN, assuming Wake on LAN is enabled, and you have vMotion interface or VM kernel enabled on that interface. But you can click properties, and it's going to query you for some stuff. So when you do IPMI or ILO, you have a username and password that you have to authenticate with. Then you have to give it the IP address of the BMC, kind of the management controller, so that's what it's talking to. And some things like IPMI will also use by MAC address. So enter all that information, hit OK, and then do a test shutdown or test standby and a test power on, and make sure it works. That's all you have to configure for this. So when that is done, we'll wait, and then I'll go ahead and boot it back up, and we'll take a look. Alright, the host is in standby mode. You'll notice the icon has changed, and if I scroll this guy to the right, it'll say, my name and in standby mode. So let's say I want to manually bring this guy back up. Now, if I go increase load and start booting VMs, it'll do it automatically. But if you want to manually do it, we right-click, and we say power on. And it'll go ahead, and it'll start powering that host back on. And again, it's got to do a full post on my servers. It's got to load vSphere, which takes a minute. We'll speed this up for you so you don't have to sit here and watch a bar go across the screen. And then I'll show you where we update the time in the settings. So go ahead and let that come back up. And also notice that we now have power management is enabled and set for automatic. Alright, that took a little bit. Now we're back, so let's check our settings, our host options, and it shows the time of the last power on. So after it goes through, it'll show succeeded. So it's probably worth at least over a course of a few days after you enable this to go through one by one, do an enter standby, and do a power on to make sure everything is good. And you don't end up with a host that gets powered off, but for some misconfiguration does not power back on. So that's it for DPM. Back to the slides. And next is enhanced vMotion compatibility, or what we call EVC. The idea for EVC is it sets a baseline for processor features in a cluster. So the point is, I'd love to be able to go and build an environment from scratch and order all the servers I plan to use for the next 3 to 5 years. But normally environments grow, and over time we get new processor generations and new servers, and it used to be an issue that we wouldn't be able to do vMotion between them without some manual filtering of what we call the CPU instruction sets, and which was a pain. EVC is a more elegant way to do that. And the idea being we can set a baseline of processor features and say, okay, all the hosts in my cluster support this baseline. They may not all support the newest, coolest features that the new servers we just ordered came with, but they all support this baseline. Therefore, that's what we expose to the VMs, and therefore we'll be able to do vMotion between them. Contrary to popular belief, I get this question all the time, EVC does not slow down a newer CPU. It just masks out features not supported on older ones. A good example is AES encryption. This was in newer CPUs, newer ones in the Vsphare family that were not in older CPUs. So, for example, you bring in some of these newer CPUs and servers into your cluster, and if you have a baseline that predates that, the AES instruction set is just not exposed to the VMs. So they can't use it, but they don't get on a situation where they boot on a host that does support it, and then they can't be vMotion to a host that does not. But all the other features of the newer CPU, the faster speed, the more cache, the more cores, all that, and anything of the instruction sets that we do allow that are just more efficient continue to work just fine. So it doesn't make the new CPU act like the old one. It just limits some things. And to be honest, most of the time when we get new instructions in a CPU, applications don't support them for a while. So normally it's not a big deal. AES may be a little bit of an exception to that because there was some things that like to do hardware-based encryption, but most things it's not a problem. You can move to a newer baseline, but not an older baseline. If you want to move it back, like you dig a couple of servers out of the closet that you didn't think you were going to use, but due to budget constraints you now want to use them, we can't easily roll back. The reason being is, if we roll to an older baseline, we have to take away some features that are in the new chips that we're using that aren't in the older ones. And so the only way to do that is to shut all the VMs down, because it's not going to let you do it if a VM is using something that we can no longer access. So be careful if you plan to add older servers to your cluster later. A couple of considerations. EVC is not magic. It does not allow for vMotion between AMD and Intel. It doesn't do any sort of translation. So it's Intel on one side, AMD on the other. You can set EVC for AMD or EVC for Intel, but you can't mix and match. Your options for EVC level will depend on processor manufacturer. So basically, what you see for AMD will be different than what you see for Intel that you'll see in my lab in a second. So just keep that in mind. But it'll make more sense because it's named them by processor family. You'll be notified if a baseline is too new for a host in the cluster. And again, I'll show you that in the lab in a minute. So let's go to the lab. So we're going to look at the existing server type, CPU type, enable EVC, and show EVC configuration options. So this is pretty simple. If we take a look, scroll over, summary on the host, you can basically see your CPU type. It shows the model number here. It doesn't really spell out, oh yeah it does. Well, that's the EVC mode. But you don't really spell it out, so you have to look up and see what generation you have. EVC is managed at a cluster level, so we'll click cluster and edit settings, and EVC. So I already have this enabled just because, I mean, all three hosts in my lab are the exact same, so they're all the same level, but I have it enabled anyway because like fault tolerance requires it. So right now my mode is Nehalem. So we can do current CPU ID detail. So this shows you some CPU registers. This probably makes no sense to you, makes no sense to me, but it's there if you need to look at it. I don't know. But you can also change mode. So you can do it for AMD, which shows all the AMD generations. You can do it as disabled if you wanted to. And every time you make a change, it'll try to validate it down here. So it'll say, okay, you can enable EVC, basically because all your hosts are the same and all your VMs are at the same level. I will allow you to do it. But to re-enable it, it might be necessary to power off running VMs. That just depends on the configuration and what the VMs have access to. Most likely, the reason you would have to power off VMs is if I had disabled it. So let's say that I had it set for an EVC level older than the CPUs in my servers, meaning we were masking features like AES encryption. I disable EVC. I then boot some VMs up that go, oh look, we have access to AES encryption. Even if they're not going to use it, they'll still see it and have access to it. And then if I try to re-enable EVC, I'm not going to be able to enable it at a lesser level. So that's kind of that warning. But I've already got it enabled. Actually, let me go back in. I've already got it enabled for Nehalem. Now, the newer stuff is Vsphare and Sandy Bridge. The older is Miram and Penryn. So let's try to go back. It's going to think about it. It's going to say no, no, no. Because powered on or suspended VMs on the host may be using CPU features hidden by that mode on Optimus and Megatron. The only reason Bumblebee's not listed is there's no VMs on him because we just powered him up from DPM. So it's basically saying, look, you've already got VMs that are powered up and see all the feature set for a Nehalem CPU. We can't strip that out. It's not going to work. So to do that, I'd have to shut my VMs down. But I can go up. So remember, I'm currently on Nehalem. Can I go to Sandy Bridge? And it'll think hard about it. And it'll say, well, no. And the reason being is the host CPU hardware does not support enhanced EVC mode because there's some features that Sandy Bridge allows that you don't have access to. So I don't have the capability to enable Sandy Bridge because my CPUs aren't new enough. But if I had Sandy Bridge CPUs and I was currently running in the Nehalem mode, it would let me step forward. Why is this important? It's important because in most cases, EVC works great. Because in most cases, you're adding newer servers and newer CPUs to a cluster. And as you add them and as you retire older ones, you can walk the EVC mode forward. It's rare that we see people put old servers back into a cluster. So it's not as big a deal that you can't roll it back. But it is nice to know, and a lot of my customers and people I work with get confused by this, and they say, well, I don't want to set an EVC mode. Number one, it makes new CPUs act like old ones, which we just debunked. And two, if I set it, I'm not going to be able to change it later. No, as you roll in new CPUs and retire old ones, you can walk it forward. So keep that in mind. Other than that, there's really nothing to set on EVC. I mean, I showed you here that you can click on a host, let it refresh, go down and say, what's your EVC mode? Click this, and it'll say, here's your supported modes. And that's the supported modes for the server hardware, for this X3430 CPU. But we can't roll back from Nehalem to Penryn or Miram with running VMs. So, yes, those are supported on the host, but I'd have to shut my VMs to do it. So, keep that in mind, that you can roll forward as you get new hardware, assuming everybody supports it, but to roll back, you're going to need to shut down the VMs. And now let's talk a bit about data store clusters. So these are different than VMware or vSphere host clusters. Data store clusters allow you to group similar data stores together. Similar is kind of key importance, and I'll talk about why in a minute. But they should be all similar performance. You don't use data store clusters for tiering. So we have a support of a feature called storage DRS, which is kind of like host DRS. Host DRS moves VMs around, balances load on hosts. Storage DRS moves VM decays around and tries to balance I/O and capacity utilization of data stores. You need them to all be the same performance in a cluster because it'll move VMs around in a data store cluster. It's not used for tiering, meaning I don't want you to create a data store cluster and have one data store made of SSDs, one made of SAS disks, and one made of slower SATA, and expect this thing to move data up and down as it becomes hot or cold. It doesn't do that. It assumes all data stores are equal, and it tries to balance the load across them. It also allows for easier VM placement. So, how many people out there, raise your hand even though I can't see you, when you go and you provision a new VM, and you get to the part where it asks you for the data store, you click and sort by free space and pick the one at the top. All right, everybody does that. Well, with a data store cluster, you can basically say, provision this VM to the cluster, and then vCenter says, okay, let me look at all the data stores in the cluster, let me figure out the one with the most free space, and it does all the work for you. So it allows you to do better VM placement. And it enables the use of storage DRS, which I just described a minute ago, which kind of does automated tiering of data stores, but it basically balances the load across data stores. So storage DRS does for storage what DRS does for compute memory. It balances disk performance and capacity utilization within a data store cluster. It can intelligently place VM decays from provisioned VMs. It monitors disk latency in milliseconds and capacity and will move VM decays between data stores if overloaded. Can be set for no automation, manual, to fully automated. So this is a fairly new feature, and most people don't trust it too much yet. So we're seeing a lot of people set this for manual, not for fully automated right now. I think that'll get better over time as people understand this, but this also leads me to another point, which is this is where VAAI array offload becomes really important. We talk about that in some of the storage lessons, where I can tell the storage array to move a VMDK from this data store to that data store without that traffic passing over storage fabric and without the vSphere host CPU being involved. So I highly suggest that if you're going to use storage DRS to kind of level the field or do load balancing of your data stores, you make sure you support VAAI offload so that you're not putting additional load on your hosts. There are some settings. There's always settings. We define I/O latency and space thresholds. So the default latency is 15 milliseconds. Once things get above 15, it wants to start balancing load, and utilize space is 80%. So VMware is going to tell you to keep 20% free space on all your data stores. So the default for this is try to keep things utilized below 80%. Now, we live in the day of 64 terabyte data stores. So I'm not going to tell you to keep a 64 terabyte data store 20% available. VMware is. I'm going to tell you that's probably a bit of overkill. As long as you're not going nuts with snapshots and things like that, you can probably do less, but those are the defaults. You may need to adjust latency depending on the underlying storage. SSDs are less. If you get 15 milliseconds on SSDs, you got a really heavily loaded data store. 15 milliseconds on SATA disk is fairly common. So you may want to adjust this up or down depending on what you're doing. And the way it works is pretty simple. Storage DRS is set so it does not move VMDKs often. You don't want this thing going nuts throwing VMDKs back and forth, back and forth. It puts load on your storage array, puts load on your host. It's not a good thing. It evaluates load by default every 8 hours. Only suggests or perform changes if it provides a significant material benefit. you can see before and after changes in the storage DRS recommendation. So the neat thing is, if you have it set for manual, you can say, okay, give me some recommendations. And it'll say, okay, here's what I think is going to happen. It's going to tell you what your utilization changes are, what your I/O load changes are, and it's going to spell it out. And then you can say yay or nay, depending on if you want it to perform the recommendations. So again, easier to show you than to tell you. So we're going to create a data store cluster, enable storage DRS, configure storage DRS, and then show recommendations. Before I do that, I noticed that storage I/O control SIOC is not in the VCAP blueprint, which I thought was a little bit odd, and maybe they consider that VCP level knowledge, but I'm going to touch on it real quick, just because one, it's quick, and two, I feel like it's something you need to know. A lot of people don't use SIOC, so I think it's worth a quick review, especially since they do spell out network I/O control in the blueprint. I find that odd, so we're going to talk about it, just so that I sleep better after finishing this and thinking that you've got a better chance on the exam. So let's go take a look. First thing we'll do is go look at a data store. I could go to inventory data stores, but I've got a really bad habit of doing everything via hosts. So go to storage, pick a data store, we'll say data store 01, go to properties. Now, storage I/O control is fairly simple. The idea being is, without storage I/O control, VMs just kind of run amok on data stores for I/O, meaning the VM that just throws the most IOs, gets the most service from the data stores, from the disks, from the host. What if we want to balance that out? What if I've got a big data mining, data warehouse application that does a ton of IO, but I don't care if it takes that thing 10 minutes or 5 hours to complete a job, but I really do care about some other VMs that I'm using. So we want to kind of balance it out, give everybody an equal playing field, or maybe even a non-equal playing field. So this is enabled on a data store by data store basis. So for data store 01, I will enable it. Then you set what's called a congestion threshold. Basically, storage I/O control doesn't do a darn thing if everything's running fine. It's kind of like ballooning on memory with VMs. If there's no memory contention, there's no reason to invoke the balloon driver and try to pull memory out of VMs. If there's no latency spikes on disk, there's no reason to force a VM to back off and slow down a process job if it's not needed. So, by default, it's 30 millisecond, which again depends on the type of disk on the back end. Usually 30 millisecond is the point where applications start to notice I/O latency and start to suffer performance. So, you may want to leave it at 30. You may want to back it down to 25. Don't go too crazy with it and set it at 5, because this thing's going to be jumping in all the time. But leave it there. Then, and I love how like DPM is just going nuts with that host. And then go to your VM. So again, let's go look at, I don't know, vCenter. Edit, resources, disk. And then we can come in here and we basically set shares, and we can limit the overall number of IOPS that this guy gets by punching in a number. So if I want to limit vCenter to 500 IOPS, I can do that. Or we can assign shares. By default, everybody gets 1,000, so we're on equal playing field. But you can up that if you want something to have higher priority, lower that if you want it to be lower priority. And really the way this works is it adjusts the I/O queue for the VMs and the host to equalize it. And it's intelligent in that it's done on a data store basis. All the hosts are aware of it. So it equalizes the load across all the hosts depending on which VMs and have shares set and what the maximums are and any I/O limits. So I just wanted to show you that. Make sure you knew how to enable it and adjust the base settings, and also saw how to adjust the VM settings. Now I can feel better about you tackling that part of the exam. So let's talk about data store clusters. So go to Inventory, Data Stores, and Data Store Clusters. Go up here to your data center, right click, and do a new data store cluster. Then just give it a name. VCAP Data Store Cluster. And then do you want to turn on storage DRS? So you don't have to, right? I can create a data store cluster that is nothing but a group of data stores, and when I provision a VM, point it to the cluster, and it'll figure out where to put it. But to get the most fun out of it, we kind of want turn on storage DRS. So then you can say either no automation or fully. There is no in between. So you can say fully. Here's where you set your advanced options. I don't really have any for you. No tidbits there, but I want you to know where they're at in case they give you one to assign. We'll say next. And here's where we set some things. So first of all, When storage DRS recommends migrations, basically trying to balance load, do you want it to consider I/O? If you uncheck this box, it only considers utilization of capacity. If you want it to consider I/O and balance I/O so the latency is balanced across your data stores as best it can, you leave that checked. Here's where the defaults are. So 80% utilized is the limit, and the latency is 15 milliseconds. So bottom line is, if your data stores are all running at 10 milliseconds, or you've got one that's running at 10 and 3 of them that are running at 5 millisecond latency, he's not going to do anything. But if one's running at 25 and the other ones are running at 10, then he is going to step in because 25 is above the 15 millisecond latency. Advanced options. So this is basically saying how often do you want me to step in. So no recommendation until utilization difference between source and destination is, by default, is 5%. So if you want it to be more significant, you can raise that up. How often do you want me to check the imbalance? Like I said, the default is 8 hours. You can set that for whatever hours, whatever minutes, whatever days. 8 hours is a decent number because it looks at the past 8 hours and says, okay, I see an imbalance. And over the last 8 hours, if I were to make a change, how significant of an impact would that have been across the entire 8 hours? If it's an impact on a very short period of time, it's not worth making the move and it won't do it. But if it makes a significant impact across the 8 hours, then it'll make the move. And then you can adjust the I/O imbalance threshold. So it's basically saying, do you want to worry about small imbalances or large imbalances? Again, I would leave this default until you have a reason to change it. Then you have to figure out which hosts and clusters you want to have access to this data store cluster. Why is this important? Because it's only going to show the data stores to add if they can be seen by all hosts. So if you got 3 host clusters here and you select all 3, if there's no data store visible by all hosts in all 3 of those host clusters, you go next, it's going to be a blank list. So it only shows things that are visible by everything you select. So let's go 1, 2, next, and it just basically says what I'm going to do, and you hit finish. So it'll create it and it'll move those in there. So what can you do? You can do things like, first of all, I need to click on what I'm talking about. You can go in here and look at your data stores. You can go to storage DRS and say make a recommendation. This looks a lot like the regular DRS screen, but it'll make recommendations and try to balance that load. Now it's not going to have anything because it hasn't been watching this but more than about 5 seconds. But just like regular DRS, it'll go through and figure this out. Hey, look, it's already starting to move some things to balance out some of my storage capacity. So that was awfully quick. I guess that's because I told it to run instead of giving me recommendations since it's on fully automated. If it had been on manual, it would have just told me what they were. You can do faults, you can do history, you can go to performance and look at the overall performance charts for this. And one nice thing that you can do, and this is worth knowing how to do, especially for the exam, is you can come in here, right-click a data store, and say enter SDRS maintenance mode. And if I say do that, oops, it's doing some stuff. It can't do it while it's doing stuff. But what you can do is you can say, you can also do it here, it'll evacuate all the VMDKs off that data store. So let's say these are VMFS 3 volumes, and you want to upgrade them to 5, but you want to restripe them to get your 1 meg block size, like we talked about in another lesson. You could put them in the data store cluster, right-click, enter maintenance mode. It'll evacuate all those VMDKs to other data stores, and then you can remove it from the cluster, move out of data store cluster, delete the data store, and then reformat it with 1 meg block, put that new one back into this cluster, and then move to the next one, put it in maintenance mode, and just walk through them without sitting here manually doing a ton of storage vMotion migrations. So that makes it very handy. But what I want you to get out of all this is how to create the data store cluster. Come in here, right-click, create, enabling storage DRS, setting your metrics, and then being able to put a data store in maintenance mode. So those are the big things that I would hit for the exam. And that's it for the lesson. So a lot of good stuff. This is actually a pretty fun lesson. I love DRS. I love dynamic power management. I love data store cluster constructs now that we have them. What I know how to do, everything we went through. So this is a great lesson for process and procedure for DRS, for dynamic power management. Know how to set your automation levels, know how to set your per VM options to disable it or put it in manual mode for certain VMs, know how to create DRS host and VM groups, know how to set your rules and what the difference between must and should rules are, know what you need to do to configure DPM for IPMI and ILO, know that to use Wake on LAN, your NICs have to support it. They have to be enabled in BIOS, and it has to be a vMotion interface. Know how to create a data store cluster, know how to enable storage DRS, and know how to put a data store within a cluster into maintenance mode. So it's a lot of stuff, but I think that's, you're going to see a lot of this on the exam, I'd imagine, because it's all very testable, it's all very tactical, and it's processes that you can do and creates a material change in the configuration of the lab that can be graded. So that's it for this one, and again, I look forward to seeing you on the next lesson.